You're staring at a blank command line, trying to test connectivity, and you immediately hit an unrecognized host error. The problem is a basic communication gap. We rely on human-readable domain names to navigate, but network hardware strictly routes traffic using IP addresses. Let's look at how this plays out in privileged exec mode on a Cisco router when you attempt to ping a well-known internet domain directly. This initial terminal output shows exactly what happens. We type ping youtube.com, and the router immediately returns an unrecognized host or address error because it has no translation mechanism in place. Without a configured translation service, the router is forced to rely on raw IP addresses. This adds a layer of manual complexity to even the most basic connectivity checks. To bridge this translation gap, step 1 is moving into global configuration mode. Here in the configuration block, we input the IP domain lookup command. This ensures the router's DNS client lookup feature is actively enabled. While this lookup feature is typically on by default, explicitly typing it is a critical failsafe in case a previous admin disabled it. Simply turning on lookups isn't enough, though. The router must be given the specific IP address of an external authority to ask. We handle that with the IP nameserver command. In this example, we're assigning a public external DNS server, specifically Google's at 8.8.8.8. Keep in mind, the router must already possess a valid outbound route to reach this newly assigned external server IP. Otherwise, your requests will drop. By defining a name server and enabling lookups, the router is now configured as a capable DNS client, ready to ask the internet for directions. Now we can verify the configuration by running the exact same ping test that failed earlier. Looking at the bottom section of this terminal output, you can see the successful translation to the 8.8.8.8 domain server, followed by the 5 exclamation points indicating successful ICMP echo replies. However, querying that external server over UDP port 53 every single time we request the exact same domain is highly inefficient. To solve that, the router relies on an internal DNS cache. This show hosts output table reveals where recent translations are saved, like youtube.com. Notice the temp OK flag. This proves the external resolution was saved dynamically and will expire based on its time to live limit. This local caching mechanism dramatically improves network efficiency by instantly resolving known domains without generating redundant external traffic. We've handled querying the external internet, so let's pivot to managing custom addresses on your internal local area network. This configuration block shows how to manually build an internal directory. We use the IP host command to map device names directly to local IP addresses. Unlike the temporary cache entries, these local manual mappings are permanent additions to the host table. The next logical step is allowing other devices on the LAN to query the router for this newly built internal directory. We activate that with a single command, IP DNS server. This turns on the router's ability to answer incoming DNS queries. Now, large enterprises rely on dedicated Windows or Linux servers for this task, but this iOS feature is highly effective for isolated labs or small branch networks. The Cisco router now operates in a dual capacity, pulling external domains for its own routing needs while serving local name resolution to connected clients. We took a router that was entirely blind to host names and transformed it into a fully functional DNS client and localized server. This reference table summarizes the workflow, comparing common Windows commands like ipconfig against the Cisco iOS configuration and verification commands we just used. Take a screenshot of this table for your personal notes to use during future troubleshooting. These configurations ensure that your router and its clients can use human-readable hostnames, bridging the gap between how we navigate and how machines route traffic.